All right, chat. The time has come to finally implement command piping for our build system in C, which is called node.h. So we already have a little bit of a kind of file redirection capabilities, but they are not really pipes that you can do in Bash. So let's actually take a look at what we currently even have in terms of capabilities of redirecting things and stuff like that. So let's actually include node.h and obviously define implementations, and strip all of the prefixes. I want to also open node.h so we can have auto completion and stuff like that. All right, so and then I'm going to accept arguments, right? Because otherwise I won't be able to rebuild myself. Now go rebuild yourself, argc argv, and now the most important thing, let's actually allocate a global object for commands, right? So here is the command, and let's just go ahead and execute some of the commands. I'm going to append the arguments in here. So let's execute something like echo, right? So it's going to be echo, and I'm going to say hello world. So do I need to put a new line? I don't think I need to put a new line. So then I'm going to do run command, right? And this entire thing may return false. If it returns false, that means it's a failure. We have to exit with non-zero exit code. So now I'm going to compile the whole thing, pipe.c, right? So, and then I'm going to be simply running the whole thing. And there you go. So what it did, it actually executed echo. Do we actually automatically escape things? I forgot we implemented that, but that's actually rather cool, right? Maybe somebody contributed that, I don't remember. So it's a hello world, and as you can see, it prints hello world. But what if I want to redirect the output of the command to a separate file? Well, recently it became actually much easier, right? So what you can do now, you can do something like file std, maybe std out file or std out path, right? So you can say, okay, output that to output txt. Right, and then I'm running the entire thing. It rebuilt itself. It ran echo hello, but as you can see, echo hello didn't really print anything at all. But if you take a look at what is going on in the current folder, there is an output.txt. Right, and then you can open this entire thing, and here you go. Here is the file. So you can already redirect input output of a single command. But you can't really redirect input and output into another command. We don't have that capability yet. Right, and I was thinking about like how would you implement such capability. So as of right now, the way you execute commands, you kind of prepare the command. Right, so you first append a bunch of arguments in here. So as you can see, I actually append echo and hello world simultaneously in a single command, but I don't really have to. I can actually split this entire stuff into two separate appends, right? And it is also valid, right? So if I now execute this entire thing, as you can see, it still executed echo hello, right? It's just like I appended all of this thing in separate places, and it is done like that so you can actually have functions, different functions that accept pointer to CMD and build piece by piece a complicated command, right? So this is why it is done like that. So running commands is kind of like a retained API. So, and because of running commands is sort of like a retained API, so you first build up a command and only then execute it, I thought that pipes is going to be kind of similar in style, right? If you take a look at what is CMD, CMD is actually a very simple thing internally. So nope CMD, it is actually a dynamic array of strings, right? So you just append strings into dynamic arrays, then you pass this dynamic array of strings to different runners, and then they spawn commands and execute them. Very freaking simple. So by the same logic, I thought that if we're going to have pipes, a pipe is going to be a dynamic array of commands. Right? Logical, right? So it's going to be a dynamic array of commands. So it's going to be the items like this. So then we're going to have a count, right? So how many we already have in there, capacity, how many of them are allocated, and so on and so forth. So you kind of like, preparing the pipe, and then you have something like pipe run, which runs each individual command, pipes them together, cleans up, and stuff like that, right? So I thought I'm going to do it like that, but if you think about it, this is not particularly convenient. Dynamic arrays of dynamic arrays in a manually managed language is a pain in the ass. It's a huge pain in the ass, because if you have a dynamic array like CMD, right, so you can append a bunch of things, but then you can do CMD count equal, and that's it. It kind of deallocated memory. It didn't really deallocate the memory. It just set the size of the array to 0. So every time you append something, it reuses already allocated memory. But if you have a dynamic array of dynamic arrays, that actually, you may have potentially a memory leak, right? So imagine that you have a pipe, right? You prepared a bunch of commands and you pushed a bunch of commands into the pipes, right? Into the pipes. And then you reset the pipe to 0, right? You didn't deallocate any internal buffers of these CMDs, but if you're gonna do append another time, the pointer to the internal buffer of already allocated cell is going to be replaced with another one, so you will literally leak memory. So this is potentially a leak in a dynamic array of dynamic arrays. So, and if you have even more dimensions, it's even more complicated. So it's not a really particularly good way to do that in C specifically. In a garbage collecting language, maybe it is totally fine, but in C it is kind of painful. So, and for a long time I didn't know how exactly do I want to go about that. And then I realized, well, it's a retained API, but does it really have to be retained? What if we make it an immediate one? Have you thought about that? Can you actually construct pipe in an immediate mode style? This is a very interesting idea. Okay, let's imagine that we have a pipe that does store some internal state. We don't really know what it is, right? So, but it's not a dynamic array of dynamic arrays, right? So, and instead of like constructing a pipe, we have three functions, three very simple functions. Pipe start. Right, so which accepts the pointer to the pipe and does some sort of initialization, and obviously it can fail and so on and so forth. Then you have another function which is called pipe chain, which accepts the current pipe and a command. And another one, pipe finish, which accepts the pipe and finalizes the whole thing. So that way, how can you develop it? Right, so you have a pipe, you allocate it on the stack, right? So, or maybe you can make it global. Let's actually make it global, similar to CMD. Right, so because we're going to be reusing this entire stuff. And then I say, okay, I want to start constructing the pipe. Okay, so this is the start. And I say, okay, so here is the pipe. Obviously it can fail, so I need to double check this entire thing. And if it fails, I return -1. All right, cool. So now the first command in the pipe that I want to have, right, I do pipe chain, is going to be maybe echo hello, right? So what I have to do is just do something like cmd append, cmd echo, and then hello world, right? So here's the hello world. Then I chain this entire thing. It spawns the process with echo, resets the CMD so you can append more things into the CMD, and maybe modifies the state of the pipe to keep track what is the last command, right? So because it's kind of important. So, and it obviously can fail, right? So you have to check for that. So after that, you will say, okay, I don't want to look at the hello world in a raw state. Let's pipe it into XXD, which is basically a hex printer. It will print it in a hex style. So if I do something like hello world, like so, and I pipe it into XXD, so this is what I will get, right? So this is what I want to do. Okay, I'm doing that, and I'm piping it into the pipe. So essentially what it does, it now looks at the previous command that was run and creates a new one and pipes their std in, std out together. And all of that in an immediate mode style. So pipe chain literally creates processes as you call it. It literally creates processes as I call it. Then you say, okay, so this is enough of the chain, right? So, and now I want to finalize the whole pipe. I do finish. And this specific call blocks until the pipe is finished, and there you go. So you do not first construct the whole pipe and then you execute it. No, you start the pipe in immediate fashion and you create chains of this pipe. And that way it is much more convenient. I don't have to really have a dynamic array of dynamic arrays, and I can actually track a very simple state within the pipe, probably just a proc ID of the last command that I executed. Right, sometimes maybe you actually want to execute this entire thing asynchronously. In that case, we can make pipe finish similarly to how you have cmd run, and you can say, okay, async and put all of that into procs array. So that thing is not going to block, right? So, and you will have entire pipe executing in the background, and you can wait on that pipe. You can flush on that pipe, procs flush a little bit later, right? So something like that. This is the design I kind of want to implement, and I think it's very doable. We already have all of the necessary mechanism to implement this entire API. So what do you guys think? Is that a good API? It's just like a constructing pipes, right? So, but in more of a immediate fashion rather than a retained one. And by the way, these like objects, this paradigm of resettable dynamic arrays is so convenient that I'm thinking that maybe Nob should provide global instances of these things so you can just like use them, right? But it's kind of bad to have them as global because maybe you have multi-threading in your build, right? So in that case, they have to be maybe thread locals, right? Not really globals, but thread locals. Flash pipe, aka plumbing. Yeah. So it's basically plumbing. I should have called this build system Mario. So yeah. That's my plan, chat. That is my plan. Furthermore, what you can do, for example, in a pipe start, you can also have parameters in here, and you can say, okay, std out, maybe std in file, not file, but path, right? So it's the path. And essentially, maybe here, instead of hello world, you're going to accept like cat. So you basically feeding input txt into cat, and it just like prints it as is, and then you feed it into xd. And in here, then later you may say, okay, std out for this specific pipe into something like output txt. So through optional parameters, you will be able to customize all of these things. And in fact, you may have optional parameters even for the pipe chains. For example, a very common operation for pipe chains is something like merge std error into std out, right? So merge them together so they are not separate things. So we may have parameters like that. And since it's an optional parameters, it's a structure, it's very easy to add more and more different parameters depending on the use cases that we discover, right? So I think that sounds pretty great. So, and in here, obviously, since it's optional parameters, all of these functions are going to be actually OPT. All of these are OPT. And in here, you would have something like a pipe start OPT. So that's OPT for that specific thing. They don't even have to be the same structures, right? So different functions may have different sets of optional parameters, and we're going to name them according to their to the name of the function, right? So this is going to be chain OPT, right? So this is going to be chain OPT, and this one is going to be finish OPT. Something like that, pipe finish OPT. So that's the functions. And in here, what you're going to have is pipe start. So here is the pipe, but then you accept variadics. Pipe start OPT, right? So this is the pipe. And in here, what we have, I forgot. So it's a pipe start OPT. Can you see Scheisse? Okay, you can see Scheisse now. So VA args, that's how you do that. Can I now do it for this one? So this is not really start. This is more of a chain. Can I do start chain? Boom. There we go. So this one is going to be chain finish. Let's go. So we have this kind of stuff now. Right. So, and now we just need to define all of these structures for all of these optional parameters, right? So it's going to be struct. Something like this, and this one is going to be le chain, this is going to be le chain, and this is going to be le finish. Fuck you, le finish. Okay. So as of right now, what do we need to implement? Do we plan to implement anything? I don't think so, but also you can't create an empty struct. So we can just have std path in here. So this one is going to be const char, so std in path. Chain opt. We can add this parameter, sure. Let's actually add the parameters that we hallucinated in here. It's kind of a long one, but it's a very descriptive one, right? So if you have any idea how to shorten it up, maybe like suggest them. Maybe it's something like merge outputs. Maybe that's better. Maybe merge outputs is already self-descriptive enough. So merge outputs. This one is going to be std_out path, right? And but for this one, by the way, so we probably have to do something like std error, right? So because you can redirect them like that. So there you go. So here are the functions. Here are the functions. So now we're just gonna go ahead and maybe put a to do in here on all of them. Can I, by the way, do that using a little bit of a Emacs magic? Emacs magic. Just see. Let's see. Chat. Look at that. Can you do that? I don't fucking think so. I'm gonna copy paste this entire thing like that. Boom. Then a to do. Like so, a boom, like so. Look at that. Absolute budgeting. std_out to std_error. Also pretty good name, right? So std_out to std_error. So std_error. It's more like std_error to std_out. It's a very common operation, honestly. So std_error to std_out, and this is how we're gonna be doing that. std_error to std_out. Thank you so much. Thank you. So what I'm gonna do, I'm going to literally just call the whole thing. So it didn't even compile because so what is it didn't like? Oh, because pipe is currently like empty structure, right? So maybe here we can keep track of something like fd_in, right? So especially if you start a pipe, you're probably gonna open the file, right? So you're gonna keep it in here. In fact, what we're gonna do about that, I'm not quite sure. So maybe we can keep it as an invalid value, or maybe as valid. I don't freaking know. But anyway, so what else do we have in here? So it still doesn't like particular as a different kind of sim. Oh, fuck you. I completely forgot. In POSIX, pipe is already taken name. Fuck you, POSIX. Fuck you. Stallman. Richard Stallman. What the fuck? Please fix. Сука, блядь. Stallman. Where did you spend all of the donations? Stop eating your feet and fix the naming, блядь. So sorry. Cheers, by the way. Stole the name, man. Stole the name. So, like, we have to call it differently now. Fuck's sake. So, we have to call it differently. So, how should we call it? We're gonna call it a PP. Okay, so this is the official name of the pipe now. So, it is called PP. Okay. So, and in here, we're gonna be accepting the PP. Okay, fuck. So this is gonna be PP. So this one is also... Man, this is fucking inconvenient, honestly. But maybe we can do something like open parent pipe and then a PP. Okay, so, well, this one doesn't really work as I expected it to work. So this is another one, this is ignored, and yeah, so overall it seems to be working. Okay, let's go. So what else do we have in here? So this is a pipe, and instead of like this pipe, I'm gonna do a reference to PP. There we go. So here is the PP. Okay, so what else do we have in here? Incompatible type parameters of toChainOut. Are you fucking serious, mother flipper? So incompatible type an expansion, so it's a pipe chain out, but you expected... I see. So it has to be CMD. All right, so this is the second parameter, has to be CMD. All right. Fair enough. What else do you want from me? Oh, you also probably want to have an async in finish. That is true. So we need to have procs, which is going to be async. Async IO. And it failed at to do. Okay, that is pretty cool. So what we can do in here, so if you provided std_in path, we probably have to open it, I suppose, somehow. So let's do std_in path, and if it is opened, what do? Is just like we do fd_in, and we're trying to open this entire thing for reading, if I'm not mistaken. So in node.h, we have an open fd open for read. So that's what we want to do in here, open for read. So we provide this specific path, but we have to be a little bit careful, right? So because it may return an invalid handler, right? So it can be invalid fd, right? Invalid fd, and in that case, an error has occurred, and we have to return false. right? So if everything's fine, we're just returning true. So what's interesting is that if path was not provided, I think we need to indicate that this thing like was not provided somehow. So I'm thinking to do that by literally setting opt-fd-in into invalid, right? So something like that. If it became invalid by opening, we're catching it right away and return false, and in that case pipe just failed generally, and in here it's invalid, so that means we didn't even try to open it in the first place. In fact, we can try to do something like this, right? So there you go. So something like that. Is that better? I don't fucking know. But anyways, let's fucking go. So opt-fd-in. So what the fuck, man? Yeah, so because this has to be pp, right? So fd is actually part of pp. Silly me. Silly me. That's how you're supposed to do that, chat. That's how you're supposed to do that. Okay. Could not open file input.txt because it doesn't fucking exist. So we're already having proper error messages in here. How about that? Isn't that a poggers? I think that's pretty freaking poggers. So we're gonna put in here, we're gonna put something like hello chat. Let's fucking go. Okay, and now it failed at pipe chain out. That's pretty cool. What's interesting is that it is a correct place to fail. It is in fact a correct place to fail. That's pretty cool. That's pretty cool. Okay, so for now, I don't freaking know. So we have to check for std error to std out, and if it is set, let's not implement it right now. So because I don't really want to go in that direction, right? So let's just say that it's not implemented yet. It's not implemented yet. But the first thing we have to do, chat. The first thing we have to do, we have to actually start the process of the command. Right, and in fact we have an internal function in nob that is capable of doing that, right? So process cmd start process, right? This one is rather interesting, right? So you give it cmd and then you give it like a file redirection things, right? So you say basically this is the file for standard input, this is the file for standard output, as standard error, and so on and so forth. We probably want to call this function in particular, right? So it's sort of like a low-level internal function for starting up the processes for the commands. This function is not intended for the end user use, right? So because it's not particularly convenient, so it's a low-level thing. That's why we made it private. So because we kind of discourage using it, right? So everything that has double underscore, that means it is private and its API can be changed without any warning. So that's our convention essentially. You can try to call these functions, sure, you can try to do that, but then don't get surprised that your code will be broken because it's private. In fact, by the way, so we have several private functions in here, several private functions. If you ever feel the need to call any of these private functions, please drop me an issue in the nob.h repo and explain your use case, right? Explain your use case and why you want to use a private function, and we can try to come up with something, right? So maybe some of the functions should be actually public, right? So because they're actually useful, or maybe create a new function that exposes necessary functionality or something like that. So yeah, don't just use them silently. All right, so just drop an issue and explain what exactly you're trying to achieve, and maybe the library is just missing something, right? So we can add that. So do not use or you will be banned. Yeah, exactly. I think it's from React. React likes to do these kind of things. So yeah. But anyways, so we need to start the process, right? So we have to pass the CMD. CMD is currently a pointer, right? So we dereference the pointer. And in terms of redirection, how are we going to be using the redirection? So it actually very much depends on whether we do have a redirection in here, right? So here is the fd in. So the way we're going to be chaining the commands, by the way, we need to be able to create pipes. Right, so we need to be able to create pipes. And pipe, by saying pipe, I mean the pipe like in a POSIX sense, right? So there's a special function which is called pipe. I was complaining about this function, by the way, but this is one of the functions that we're going to be calling today, by the way, We're going to be calling this function today. So it accepts an array of 2 integers and it returns a pipe, 2 file descriptors, 1 file descriptor for reading and another file descriptor for writing. And if you write something into the write file descriptor and try to read from the read file descriptor, you will get that exact thing. That's a pipe. So what we want to do, we want to create a pipe, and for the input of one process, we want to put the output of another process. So that's how we're going to be chaining them together. But on top of doing that, it has to be also cross-platform. Right, this function is a POSIX one. We also need to be able to do that on Windows. Right, so we need to abstract away this functionality of the pipes. Because of that, we probably need some sort of a entity similar to FD. Right, so some sort of a entity which I suppose we have to call pipe, and it's going to be something like FD read and write. And the only logical name for this thing is a pipe, but we already have taken pipe. So that means we have to call this thing differently. For fuck's sake. So how should we call the thing? Tube. Chain. Chain is a good name. Okay, so, and this entire thing should be called chain. And that means that this name is invalid. We can't call it PP anymore. So we should call it chain then, right? So, and now if we're gonna have a function pipe chain, we should call it chain? Yes, we're gonna call it chain. So do naming, man. Like, naming is one of the most difficult things in programming, am I right? It's just Jim. Oh, Jim, kind of. Okay. Why do I always end up with these silly names? Jim, and chain. We can call it like a continue or cont, right? But it sucks. I think it sucks. So I'm gonna call it chain. For now, at least. At least for now, I'm gonna call it chain. Alright, so let's try to compile this entire thing, because we changed some names, so we need to... Link is a good name. Or, yeah, okay, so you guys are actually suggesting cool names. Link could be a good name, but it kind of like has this weird implications that maybe you're linking a file, like a symlink, or maybe it's a... I don't know, like it's kind of cool, but at the same time it has a weird implications. Something like append could be good, or maybe chain next. Chain CMD, also pretty good name. Append, no, we're not really appending anything to anywhere, like internally, we're just creating processes. Chain CMD is a good one. Chain next is a good one. Like, I kind of like chain CMD. Yeah, chain CMD is actually perfect. You know why? Okay, listen. So chain. Because literally, the first 2 arguments of these functions are chain and then CMD. Absolute budgeting. Thank you so much. So who suggested chain CMD? But thank you whoever suggested. I already lost it, but that's actually perfect. Chain CMD. So yeah, absolute budgeting. Budgeting. So let's actually rename pipe to chain. Okay, so let's go through all of this scheiße. So chain start. Chain OPT. Okay, so we've done that. So prox flush and stuff like that. Okay, so, and now we also have to rename le pipi. We're gonna rename it to chain as well. So this is pipi. Let's go. Okay, so let's replace chain opt, chain cmd opt. So that's the actual name of this structure now. Let's go to the compilation errors. What the fuck is a chain? So it's like when you replace PP with chain. PP. Chat, now you are acutely aware of the fact that you can't spell append without PP. You're welcome, chat. You're fucking welcome. Anyway, so a chain. Let's quickly replace a chain with append. Yeah. A pp end. So knob fd. Okay, so I haven't finished this entire stuff yet, so let's actually do to do this one is a chain cmd, and in fact maybe I can do something like chain chain cmd, just like replace it like that in all of these places. Yeah, there we go. Let's fucking go. Okay, cool. We've refactored everything. So now I can easily create the structure called pipe. Right, and now I want to be able to create the pipes, right? So there should be something like pipe create. So I'm not sure if it's going to accept any parameters, like it doesn't really need any parameters, but the idea is it's going to create the pipe, right? So, and creating the pipe is rather easy on POSIX. So let me actually see. So we already know how to do that. We just have to call this specific function. So it may return some stuff. In case of returning some stuff, we have to log this stuff. So we're gonna, well, okay. So this one is interesting. It may return an error, right? So because of that, it should return a Boolean. So that means we have to put the pipe in here like that. And again, the word pipe with small letter is already taken. We still have an opportunity to use pp in here. Perfect. So it's going to be called pp. So, okay, so we have a pipe fd, right? So we're going to do pipe fd like so. Put it in here. Then we're going to do log error. And so then we're going to say could not create pipe. And then we're going to explain the reason why we couldn't create a pipe. So it's going to be str error, std error, error null, like this. And then we return false in here. In here, we're going to return true. But on top of returning true, we have to set the read and write end of this entire stuff. So read end, I don't remember. I think it's just like literally 0 and 1. So read and write end. Am I correct, chat? Am I correct that these are the ends? So read, so creates a pipe. Okay. So 0 refers to the read end of the pipe. Pipe fd, like 1 refers to the right end of the pipe. Okay, so I think we did everything correctly. But this is only for the POSIX. We have to also do that on Windows, right? If def win32. So this is going to be else, like so. So to do Windows is not support. Creating pipes on Windows is not implemented yet, like so. There you go. So and in here is going to be and if. Who remembers how to create the pipes on Windows? So win API create pipe. So I remember that it was also like a single function, right? So pipe function, okay. Pipe, oh yeah, so it says like create pipe. It's create pipe. And yeah, well, look at it. So you have to even pass that handle by point, which is even more convenient, honestly. You also have to provide the size and stuff like that. So for now, I'm gonna actually just put sort of a, you know, this link. So I'm gonna also say C. We can even try to maybe pre-call this particular function, right? So just like roughly outline how it's supposed to be used. Roughly outline. So we also can do the following thing where it's a read end, so we can pass it like that. And it's totally fine, by the way, because fd, depending on the platform, is actually defined differently. On POSIX, it's just an integer, but on Windows, it's literally going to be handle, right? So it is cross-platform thing in a sense, right? So knob fd. Yeah, there you go. So as you can see, if it's on Windows, nobfd is literally handle, but if it's POSIX, nobfd is int. Right. So because of that, taking a pointer to that on Windows is totally fine, and we are in fact on Windows, so we can do this kind of stuff. So this one is a pp write. I'm not really sure about security attributes. I suppose we kind of have to allocate them on the stack, right? So because it's LP, which stands for long pointer or whatever, and it's also, as you can see, input optional. Does that mean I can just provide a null in here? I don't really know. And in terms of size, I'm not really sure what size should be. Maybe there are some examples in here. Okay, so this one is optional. A pointer to a security attributes structure that determines whether the return handler can be inherited by child process. Okay, so we're getting into like a really weird territory. Because of that, let's not implement that yet, right? So what we're going to be doing is probably just passing this stuff like that. Maybe like I don't know, right? So let's just put like comment it out. Right? That's roughly the idea, right? But since we're only outlining this entire API, it doesn't really matter. We can always do Windows later. Okay, so we have an ability to create pipes. So what we have to do now is create the pipe. We have to create the pipe because we're going to be creating the first command, right? So we're going to be creating the first command, and we need to give it as an output one end of the pipe, so then it can be used. Then it can be used for the next command, right? You see how it goes, right? That's basically the idea. That's basically the idea. So let's actually see how we can do that. Pipe create. So this is going to be pipe pp. And in here we give it a pointer, and it may fail for whatever reason, right? So we have to return false in that specific case. Okay, so now what we have to do, we have to create the process. We're creating the process. We give it cmd. The input has to be you know, whatever we put in there, whatever we have in the chain already, because in the chain, where is the chain? You have fd that we inherited from the start, right? So that means this has to be fd in. But if it's invalid, we should not provide it, right? So the way start process works, let's actually take a look at how it works. It accepts fd in, fd out, and fd error by the pointers, and if those pointers are null, it's going to just use the standard stream, standard input, standard output, and standard error. So we have to be kind of aware of that. So what that means is that we need to have some sort of like a pointer, pfdn, right? And by default it is null, but if inside of that chain fd is actually not set to invalid fd, we have to set that pfdn to the pointer to this thing, saying that okay, it is actually in fact set for us, and this is the thing that we have to use in here, pfd. Right. So something like this. And in terms of standard output, well, this one is rather interesting. So standard output, we have to put one end of the pipe in here. So pipe has to be right? So we given it the right end of one pipe. So maybe it would be actually nice to have something visual in here, because I'm currently, when as I'm writing this entire stuff, I actually have a visual representation of what is going on in my head, but you can't see that because you can't read my mind. And in fact, this is a skill issue. Learn how to read my mind already. Okay, so let me see. When I start the chain, I actually have a file descriptor for input ID, right? Input txt, right? So here's the input txt, and I open that file and I have a fd in of that thing, fd in. Okay, so then I call chain cmd, and that creates a command. It literally spawns a command, right? It spawns the command. And another thing I do is that I create the pipe. And the pipe has two ends. It has two ends. It has basically read end. So this is actually, it has a write end, and it's kind of difficult, but we can think of it like this, right? So this is basically the read and write ends and stuff like that. So on a start, we created this. Then we are about to spawn the command. And as we spawn the command, we're actually feeding this file descriptor of this thing as the input for this command. So that's literally what we did in here by providing pfdin. So if it does exist in the chain, right, it's not equal to fd, so that's what we're going to be putting in here. All right, so now as the output of std out, we have to take the right end of that pipe. We have to take the right end of that pipe. And that's literally what we do with giving the pointer to pp_right. That's literally what we do. Right, so this is basically from the previous thing, and this is the current thing. I'm not sure what to do with the file with the error, with the std error, honestly. Not really sure what to do with it. Maybe for now, I'm gonna set it to null. Right, basically do not redirect standard error, right? So maybe something gonna be about std_in, but yeah, basically, or maybe it's going to be like in here, right? It has to be probably addressed by this option. It has to be probably addressed by this option, right? Yeah, so maybe because of that, do I need to create a separate to-do, or do I not have to create separate to-do? Because I think, yeah, okay, so when I'm going to be working on that, I think I'll figure out what to do in here, right? I think I'll figure it out. Okay, and now, what I think I have to do, I have to now save this as the next fd_in. Right, I literally have to do this thing where I just say, okay, now in the chain, fd_in is the read end of that pipe. So then, when I start another CMD, I can literally continue this process. You see what I'm doing? Right, this is going to be CMD, right, CMD. I created the CMD, then I feed that the same fd_in into the input of that thing. I create new pipe. And it's literally like a recursive process, right? So it's self-replicating process. You can chain things like that. So, and so on and so forth. So, and then you create a pipe. And you don't even have to keep track of any of these processes, but maybe you do, right? So maybe we need to actually collect all of these things into our own procs list. So then when you want to run this entire thing in a synchronous fashion, we append all of these IDs of all of these commands into that asynchronous, but we'll figure it out, right? So none of that really matters. What we have to do is establish the general process of piping these things, right? So details can be figured out later. Details can be figured out later. So what's interesting is that I feel like once we kind of consumed these file descriptors, we can close them. This is what I remember. Like as soon as we kind of passed this file descriptors to the child is done with this file descriptor. Child has its own copies of this file descriptors, and on the parent end, we can simply close them. This is what I remember, actually. This is what I remember. And what's funny is that we always have something in fd_in, don't we? We kind of always have something in fd_in, which means that maybe this entire fluff with checking is it set, is it not set, blah, 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 it's not really needed. And what we can do is just like a chain fd_in pointer, and let's get rid of that. And this is literal chaining. And then we can simply fd close. I remember there was fd close where I could do chain fd, right? So this is a chain fd. And I also now closing pp_right, but I'm saving pp_read as the new one. The only time fd is not going to be set is only when we didn't provide std_in path in here. That's the only time it is not going to be set. But you know what? Why not we just set a standard input? Fuck, you can't really set a standard input in here because it's going to close it, right? You don't really want to. Yeah, I can put a standard input in here, sure. I think it's a std_in file number, but then in here it is going to be closed, right? So it's kind of an interesting thing. So you probably don't want to do that. And by the way, you only want to do that if only you're not on Windows, right? So this is going to be something. On Windows, you probably want to do something, but on POSIX, you want to do something else, right? So and if to do so something like that on Windows. Set to 0. 0 isn't 0 std in. Well, it is std in here. Look at that. So not 100% sure. So maybe okay. So maybe we should allow it to be invalid. I feel like we should allow it to be invalid because it's going to be just easier and more cross-platform. We're going to be setting it to invalid, and let's just do that fluff, right? That I didn't want to do, but it is what it is. Let's just have some fluff. fd pfdn initially null, and if chain fdin not equal invalid id, maybe I'm going to even do something cool, is that now it is a pointer to this entire thing, like so, and we're just doing the pointer. So pfdn. And we're closing this entire thing only if it is not null. I guess that is reasonable. It's a little bit like hairy, I would say. It's a little bit hairy, but it's more cross-platform. Doesn't really require doing fdef somewhere up there. Right, I think it's fine. I think it is totally fine. But anyway, so that's basically it. And here we can just return true. So we implemented chain cmd opt. We literally implemented it, right? So we didn't implement this thing, right? So, but we can do that later. Yep. So, and we're going to continue chaining. So we can now try to maybe run this entire thing. It's probably going to fail for a really weird reason, because I tried to actually merge these two things together, right? So down there, right down there, I literally set it to true. I set it to true. Let's not set it for now. Let's not set it for now, right? So we're not working on that right now. Okay, so, oh, funnily enough, it calls them. And another interesting thing I noticed is that it doesn't reset like CMD. One thing that this thing doesn't do, it doesn't reset CMD. So what that means is that we have to do CMD count equal to 0, right? So XDD, yeah. So as you can see, it already sequentially called cat XDD, and then it failed at finish. We are already on basically a finish line towards implementing the pipes. So that's pretty cool. So what we're going to be doing here, so in the finish, we do the redirection, I suppose, I think. So this is going to be finish. Yeah, so we can also do async and so on and so forth. So for now, let's just do the following thing. I'm going to just remove all of that stuff. So, and this is now OPT. Okay, and I'm going to just like mark them as not implemented yet. So if you set any of these things, we're going to do to do chain finish OPT, this thing. None of that is implemented yet. So for to do, let's do relative indent. Cool. So we're going to just assume that none of that is really set. None of that is really set. And interestingly enough, what I have now is fdin in the chain. fdin in the chain, which I have to do something with. I have to redirect it back to the standard output. Wait. Do I literally have to now keep reading fdin chunk by chunk and print it to standard output in finish? Is there any way, cross-platform way, to take the, you know, the file descriptor for reading and just flush it into the output? Can I do something like send file, maybe? Send file. Well, I can do that on Linux, right? So this is basically the right. So you have an output file descriptor and input file descriptor, right? And you just like sending. So there's a splice. Yeah. So people suggesting send file. What about splice? Never heard about splice. What is splice? So splice data to and from pipe. Ooh, this one is interesting. Never heard about it. Move data between two file descriptors without copying between kernel's address space and user address space. It transfers up to. That sounds interesting. Is there something like that on Windows, by the way? Is there something like that on Windows? And what's funny is that that kind of also implies that we have to copy, like that we have to block on finish always. But what if somebody provide a sync, right? So we have to continue like outputting this thing into the standard output regardless of whether it's set or not. So it's kind of weird. I'll need to think about that. So yeah, I need to think about it. I'm already streaming for almost 1 hour, right? So here's an idea. Let's make a small break. I'm gonna make a cup of tea and I'm gonna be thinking like how we can organize this entire stuff. Maybe we can postpone a creation of the commands, right? So one idea popped up in my head is that you do CMD, but it doesn't really do CMD. It postpones it on until the next CMD. So then when you do finish, you have one command in there. And you only then run the last command and do all of the necessary redirection in there. We can do something like that. So that will imply that inside of the chain, you're going to have like an internal CMD like that, which basically holds the previous command, right? So holds the previous command. Oh, finish takes the final command. I don't want to do that, honestly. I don't want to do that because it kind of makes it difficult to append more commands in here. You know what I'm saying? So if finish have to, well, actually no, not really. So you already have this as the final command. Now you want to append more. Before, to append more, what would you do? You just take these two lines and copy paste it, and there you go, you append it more. You want to append more? There you go, you copy paste it, append more. No problems whatsoever. Now, if instead of using chain CMD, you have to use finish, how do you append a new command? Well, now you have to put this thing in here, and it's kind of bizarre. You know what I'm saying? It's kind of bizarre. I don't think it's particularly convenient. I don't think it's user provides the final ID. I don't want the user provide the final ID, FD. So I kind of want to go with the idea that, yeah, when you do chain CMD, doesn't create command right away. It only holds it and waits until the next chain CMD or chain finish. And it's not that difficult, right? So you just basically hold on the previous command, right? So that's what you do. You hold on the previous command. And it's not like we have a dynamic array of dynamic arrays in here, so I don't think we're going to be leaking too much. So again, let's make a small break. Let's make a tiny bit of a break. I'm going to make a cup of tea. I'm going to think, and we'll see how we can go with all that. All right, not immediate much. That is true. Okay, that is true. But even immediate UIs are not that immediate either. They're not that immediate either. They usually have begin and end. Right, so they define blocks begin and end. And as you have a lot of nested begin and end blocks, they usually have a context, an explicit context, or implicit context as a global variable, where they keep track of what you've been beginning and ending, building up some sort of an internal state, and they may flush that internal state at the final end as well. So they're not that immediate either. They also retain a little bit of the information as you're doing the immediate thing, right? As we're doing the immediate thing. So because of that, I don't think it's that big of a crime, right? So, and I don't think it is even possible to make anything perfectly immediate. There's always a little bit of a state going to be retained somewhere. So that's totally fine for me. That is totally fine for me. But anyway, so let's make some break. We are back. So I think I made up my mind on actually retaining the last command. Let's actually go with that idea. So, and I think it will solve some of the problems. I'm not sure what kind of problems it may then introduce, but this is kind of the point of trying it out and seeing for ourselves. So we're gonna literally keep the CMD, right? So we're gonna have like an internal buffer where we retain the whole thing. So when I'm starting the whole thing, I'm just keeping the file descriptor, I'm gonna leave it as it is, right? I am leaving it as it is. So then I do, you know, chain cmd opt. And what's interesting is that that means I need to retain some of these options in here, right? So, which means I probably need to, yeah, I need to keep them along with the cmd that I'm about to run. That makes sense to me, I think. That in fact makes sense to me. So let's actually do something like chain cmd opt, right? And that's basically the options that we retain. So on the next chain or the next final, we're going to be using those options to chain all of these things properly. Hopefully. And here is an interesting thing. So what if, is it the first chain in the whole block of chain? Is it the first chain CMD between start and finish? Yes, CMD achained. Yes, CMD achained. Is that the first one, or is that the not the first one? Because that's kind of interesting. So you do start, then you do chain CMD, right? So I'm gonna omit the chain prefix, right? So this is gonna be that finish, right? So when we need to know whether it's the first one or not the first one, so we can kind of distinguish whether it's the first one or not the first one by taking a look at the CMD itself. Is it an empty one or is it not an empty one? And by the way, I want to cross out the previous implementation, so everything below that is what we implemented before. None of that really matters, right? So this is the first CMD in the chain, not first CMD in the chain. And what we have to do if it is literally the first CMD in the chain, well, we don't really have to do anything except saving that CMD. So we could have done something like this, but this is not a particularly great way of doing that. I think we need to sort of like drain this specific CMD into the internal one. If I remember correctly, knob.h had something like the append menu. Yeah, there we go. So you can da append many into the internal CMD, and we can just do CMD items and CMD count. So we're taking everything from that CMD and we appending it into that one. So after that, we kind of have to drain that in a CMD, set it to 0. But here is an interesting thing. What if somebody did a chain with already empty CMD? If we're using empty CMD internally as an indicator that this is the first command in the chain or not first command in the chain, we should not allow using empty CMDs in here. So that's kind of an important thing. It's kind of an important thing. So, which means that we kind of have to assert that this thing is not empty, right? That's our implications in here. So this is very important. So this is the first CMD in the chain, and we kind of save it. Another thing we probably want to save is also the options with which that previous chain CMD OPT was called, which makes the whole thing a little bit more complicated. So I'm not really sure if we're solving any problems here, but that's the whole point. We're trying to figure out what we're solving and what is not really possible to solve. Right, so CMD chain, chain CMD OPT, so this is that, and I'm just saving that OPT in here. I'm just saving that OPT in here. Cool. So we retained the whole thing, essentially retained the whole thing. So now, what do we do? Now we have an else branch. And in fact, we might as well just get rid of the else branch and just return true in this specific case, right? So everything below is the else branch. And in the else branch, we literally have to create the previously retained command. That's what we have to do. We have to create a previously retained command. But now, instead of using this OPT, we have to use the one that we saved in the chain, right? So this one has to be chain, chain CMD OPT. And funny enough, we have to prefix chain too many times. So if you take a look at the structure chain, yeah. So we already kind of know that this CMD OPT is part of the chain because it's inside of the chain structure. So for this specific thing, I don't think there is any point in having this prefix. So we have CMD and we have CMD OPT. That is fine. That is totally fine. Nothing else is needed in here, I think. So that means in here, when I'm saving, this is just a CMD OPT because I don't really want to duplicate the prefixes too much, as in here, for instance. So here's the chain, CMD OPT, previous one, and this is what we're doing in here. So maybe it also makes sense to describe where we have this entire stuff. Okay, so that's the thing. So we create the pipe, we create the pipe, then we do pfdn, and this is fdn and so stuff like that, and we create a process, but we create the process not for this the current CMD. That's the thing. We're creating the process for the one that we retained, chain CMD, and so on and so forth, right? So, and we also, as you can see in here, resetting the command, and I suppose the command that we have to reset in here is actually the one inside of the CMD, right? So all of that, as you can see, sort of kind of shifted. Then we're closing everything in here, and here is the FD. Okay, so we adapted existing code to creating the previous command, not the current one, right? So let me double check that. OPT, how OPT is used in here. Okay, so it is used correctly everywhere, right? But now we have to repeat this kind of code again and save whatever the user provided in here. Okay, so how we're going to be doing this entire stuff? We might as well actually copy paste the whole thing in here like so. We're copy pasting the thing in here like so. So here we spawned the previous command. We already cleaned up an internal buffer, right? We already cleaned up. By the way, why did I type this? Like, I specifically typed this line to say we should not do that because it's dangerous. And then I forgot to remove this line. Okay, I'm glad that I noticed that. So this is a dangerous, like I specifically typed, we should not do that, and I just left this command in here, the one that we shouldn't do. For fuck's sake. Anyways. So, okay, and we literally do the same code, honestly, right? So if you take a look at the code in here and the code in here, it is literally the same code, which means that we have to deduplicate that somehow. So what I'm thinking is, we should put that block under the condition. We should put that block under the condition, and essentially, if it's not the first command, which is, yeah, chain CMD, CMD count not equal to 0, not the first command, we do this thing, right? So we spawn this command, and then we always do that. Look at this, right? So we had duplicate code, and now I compressed it. So you try to run it, it's not the first command. We start the one that we previously saved, and then we replace it with this one. But if it's a first command, this entire block will be skipped, and we just like use this one. This is better. This is more tight. So yeah, that's basically what we have to do in here. So that's pretty cool. And by the way, we may actually have an interesting situation that we'll have to reuse this code in the finish. Right, so that's what we'll have to do probably. So can I now try to run the whole thing? It doesn't compile, right? So, and this is because chain CMD OPT has to be defined a little bit higher, right? So it has to be defined like somewhere here. All right, so what else do we have? Anything here? So it's somewhere deep in here. So what's going on? I forgot to put a reference in here. What else do we have? Okay, and this is finish OPT, right? So, but it's has a to-do, so we don't really care about that. And yeah, this is rather interesting. So we have options of the finish OPT, and we have the options of the chain CMD. And both of the options are going to be used simultaneously to create a new command. And here's an interesting thing. So what if I somewhere did start and finish? What if I did something like that? I guess nothing should happen, right? So we just like, if you don't have even a single command, just do nothing, right? So just do nothing. But in the start, you may open the stdin path file. So we should at least try to close this file, right? So something like that. So let's go ahead and try to. It's kind of going to be similar to this stuff. I feel like it's going to be similar to this in structure. So let's do it like that. So this is first command. We're probably going to be reusing this code. And if it is the first command in here, what we probably have to do, we don't really have to copy the command. We have nothing to copy. We just have to reset this thing to 0. We can just omit cmd as it is, like it doesn't really matter. And one other thing I probably have to do, right? So if fdin is not equal to invalid file descriptor, just close it in case you didn't provide any like command lines or anything like that. So that's probably the thing we want to do in here. I'm going to put it to do in here because this one is not implemented yet. And that's already an implementation of an empty chain. Yeah, begin drawing, end drawing. This is kind of what we're doing. We can even rename start and finish to begin and end. Okay, so start, begin. Now it is a begin. Finish, end. So now it is begin, chain begin, cmd, end. Is that better? And by the way, another interesting name for chain cmd, we can call it chain pipe. So maybe not, I don't know. So is that a good name for this kind of thing? But yeah, so begin and end, chain ending. That's pretty cool. As already said, this is basically a valid implementation of just an empty chain, right? It's a valid implementation of an empty chain. So this should already work, kinda. I think it won't work because we provided async and std out path. So it's going to actually crash in here. So cmd implicit declaration of nop cmd process. Really, is it implicit? Oh, because it's already the second time where I fucked up naming because a query replaced everything. This is supposed to be cmd start process, obviously. Yeah, so it's a fucking classic. So cmd, we restart the whole thing. Right, so we don't even have to restart this one. Yeah, so what we have to restart, in fact, is just chain, like so, I think. But I feel like it's going to be done automatically for us. So this particular code is probably going to be changed as we implement this part, right? Because I'm not really sure how exactly to do this thing, unless I know how I'm going to be doing this thing. That's a good point. It's actually a good point. Anyway, so this is fd, but it's more like a chain. It's not fd, it's a chain fd. There we go. It is not implemented because it wants to have std out path, right? So let's not provide this option yet. And also async. Let's not do async for now. Right. So, and this particular use case should be implemented. So chains are effectively implemented for this use case where you have begin with a standard input and then end. So it's kind of a useless use case, but it's a basic it's a baseline upon which we can put more features, right? That's kind of important. So it's important to implement simple use cases first. Right, I think it's kind of important. Now let's try to implement like the chaining. Let's try to implement the chaining. And of course, it failed in here, right? So it instantly went in here and yep, let's fucking go. So the first thing we have to do, we do not support standard error into std out, but it is in a different function. It is end, right? So I have to at least change the naming in here. Okay, so this part is done. Next, as usual, we probably create a pipe, but it kind of depends on whether we're redirecting to the standard output or not redirecting to the standard output. So whether we're going to be creating pipe depends on whether we're redirecting or not redirecting. And this is the first deviation from that previous command. And okay, so that's a thing. Let's bring this thing down there. So this is opt std out. Opt std out. If you want to do std out and you want to redirect it to a file, I guess you just have to do fd out, right? So this is going to be fd out and its pointer, let's call it pfd out. It's a pfd out and initially it is null. If you want to redirect this entire thing, you have to, well, you at least have to have that file descriptor somewhere to which you're going to be referring. So let's have it as fdin. Let's have it as fdin, but maybe not. Let's keep it like that internally. So fd open for writing, and I'm opening this whole thing like that. It may obviously fail, so it's going to be invalid fd. So I want to cross out this thing like that. Well, I mean, I can use to do as crossing out, right? So everything below that is unknown, not implemented. We don't really know what to do with it, right? So that's how I'm doing that. Okay, so if it failed, return false, right? So it failed. If it didn't, that's the new pfd out. That's the new pfd out. Right, and okay. And that's basically, I feel like in the finish, we don't have to create a pipe. That's the whole thing. We don't have to create a pipe. That's why we need retain commands, and that's why we need this finish thing. Okay. So, and in terms of pfdin, it is also rather interesting. All right, so because you may have only single command in here, and you still need to do the piping for the single command. So you have pfdin, pfdin out, right, then you are spawning the process for the chain and the command and stuff like that, but here you're going to be using pfd out. All right, and after that, you are resetting the internal buffer to 0, resetting it to 0. Here we're closing the input, but now we should not forget to close the output as well. pfd out. All right. So here we're closing the pipe, but we never created pipe in here. And here we're doing the chaining for the next chain cmd command, but we don't have that. All right. So as you can see here, we are doing chain cmd 0 2 times. So that means we don't have to do that in here. And also we're closing fdin just in case. We're closing it in here if it actually exists, so we don't have to do that here. Remember how I said that this part down there is going to be different depending on how we implement this thing? There you go. Actually, it should not exist. I didn't know that up front. I just felt it. I just felt that it's going to depend on what we're going to be doing in here, and in reality, we don't even have to do that. So the thing is that people try to like predict the code up front, which I think it's a kind of a failure strategy. You have to let the code evolve. The code itself kind of knows how it wants to implement itself. I'm not sure if I make any sense, but over time, as you develop more and more, you realize that the code kind of lives its own life, right? You have like very little control over how you can write the code. You can kind of push it in a certain direction. And the reason why it feels like it's living its own life is because it has a very, like it has restrictions, right? So it has a certain restrictions, and you can't move it to, different, control it too much, right? So everything kind of falls in place. And it's not even, I think it's not like it has its own intellect. It's more like playing Tetris. In Tetris, you kind of control where the pieces go, but ultimately it's the chain of all of your previous decisions that determines what you can or cannot do. It's kind of like that. In a sense, you can say that the Tetris state of the game of Tetris is living its own life, but its own life is the chain of all of your previous bad decisions, essentially. So, and it's kind of, code is kind of like that. It's like playing Tetris. That's why I don't really play much video games lately, because I can just code. It feels like a video game already. That is not true, by the way. I recently started to replay some of the games from my childhood when I had Sega Genesis. So I just like downloaded a bunch of games and Sega Genesis emulator, and I'm just playing the games. I even have a, where is it? Gamepads. So I even have a gamepad, so I play it with a gamepad. It's actually kind of cool, right? And I'm able to do things that I couldn't do when I was a child. Right, which is basically save at any point and restore it at any point. So the thing about games for Sega Genesis from 90s and 80s is that if you die, you have to start the game from freaking scratch. And the game are usually like decent in size. They're decent in size. Like imagine you go into the last stage and you completely die. You have to start from the start. So there's no memory in there or anything. So because of arcades. Well, yeah, so it's kind of because they needed to run them on arcade machine, right? So but anyway, so yeah, but now I don't have to worry about it. I can just like save the state of the entire emulator and don't worry about it. And also for the money, yeah, so you need to milk the kids for the money. Do you like RTS games? Some of them, like I used to play Warcraft 3, which is an RTS game, but I was never really good at them. That's the thing. I was never really good at them, so I don't know. So I think that's basically everything, right? So that's the whole thing that I wanted to implement. So the chain end shares some code with chain CMD, but it's not exactly the same. I can't really exactly reuse the code. So yeah, I'm not 100% sure how we're gonna go about that, but anyway, so let me actually get rid of this code. I want to comment it out. I don't want to run it right away, but I want to test if it builds or not. Obviously it doesn't build because another place where I accidentally replaced start with begin, and it compiles. Okay, so that's pretty cool. So now one thing we can try. So here is the empty chain. Begin, end, just an empty chain, nothing more, nothing less, and it worked, right? So we can try to get rid of the file. So hello chat, I'm going to put back in here, and it couldn't open this file, right? It's kind of an interesting chain in a sense, is that, yeah, you try, you don't really do anything, but one of the things you have to do is to do that. Oh, by the way, so I just realized, if you have an empty chain, you have to at least close the file. That's true. So you have to at least close the file. So in here, if it is empty, and it is an empty chain, so let's take a look at this. So if d in equal to invalid of d, if it is not equal to invalid of d, at least close the whole thing. Right, and we can maybe set it to invalid. Maybe it doesn't really matter, right? So you can just set it to 0. Okay, so that's kind of important. And by the way, we also have to do the assertion. We have to do the assertion that, well, yeah, so we have to do the assertion that you didn't provide the empty command, but you don't provide any command for the end, so it's totally fine. So I don't have to do this assertion here. So anyways, yeah. I just do that, couldn't open the file, but then if I do something like that, I should be able to open the file. Okay, so next use case, let's just start cat. Starting the cat is very interesting. So it's supposed to pipe input txt into cat, right? At least that. It's supposed to do at least that. Now, let me also remove output txt, just in case. Okay. Didn't do shit, by the way. Didn't do shit. But it's supposed to, I think. It's supposed to, I think. So let's see what exactly is going on here. We might as well actually try to maybe even debug, just to see what's going on. Let's actually try to debug this entire stuff. But that just means I have to recompile the whole thing with, you know, GDB. GDB pipe.c. Let's go. So it's going to be a gf2, I should start it like that, gf2 pipe break main, and let's just run the whole thing. Okay, so do begin. I might as well take a look at the chain. So what's inside of the chain? Okay, so file descriptor is 0, CMD option, none of that is set. I do that, and in the begin, well, I mean, okay, so that is understandable, so that's totally fine. All right. So I do that, so there should be CMD in here. So here is the internal CMD. So there's only one thing in here. I do the next chain CMD, so this is kind of important. It reset that CMD, but then internally it saved that one command that it needs to run now. Let's step into chain end. Okay, all of that is totally fine. Then we go here. Okay, so this one is interesting. We never really said this thing, so that's totally fine. We didn't provide std out. So that means this thing should stay null. For the standard input, we do have fd in and fd out. Okay, let me take a look. So pfd in, so it does exist. Pfd out, it is null. So that should work effectively, I think. And I think I know where I fucked up. So startCMD just spawns the process and it returns the proc ID. So what I have to do in here is I have to wait on it. Silly goose. I forgot to wait on this process. So yeah, so one of the advantages of the debugger is not only that you can observe the state of the program, but it also kind of forces you to go step by step and mentally just understand, are you doing the right thing? No, I'm not doing the right thing. So I think somewhere on Twitter or maybe Blue Sky, I don't remember where, I compared using debugger like that to flipping the illustrations when you're drawing. Artists, people who draw, they know this trick is that when you're drawing, you kind of get into this weird mental state where you can't notice mistakes that you're making while you're drawing. One of the tricks to get to reset your mental state is to flip, is to mirror your drawing, and all of the mistakes that you've made become apparent. So this is kind of a similar effect, right? So I could look at that code myself and I probably wouldn't notice this mistake that I never did this proc and so on and so forth. But because I will step debugging in a compiler, it kind of reset my mental state, and now I'm like acutely aware of this thing not being set. Does it make sense? Do we have any people who actually draw in here in the chat? So I feel like it is kind of akin to that. It forces you to sort of change your mental state. Kind of a code review. Yeah, maybe. So that's actually true. You mirror it and immediately realize it looks shit. Exactly, right. So there are some people who draw in here, so people know. People know. It always looks like shit. Well, if it always looks like shit, this is a completely separate problem, right? So it has to be solved differently. But anyway, so we have to do proc, wait, and just wait on that proc. And in here, since we are, yeah, we can just like return, right, whether it succeeded or didn't succeed. So then we can do something like that. And since it's just like this else, I can do something like that. So, and here we have an interesting case of empty chain case. So, all right. So I suppose now this should work. I need to only just run pipe, and it actually printed hello chat. So look at this pipe, dude, look at this pipe. So we begin the pipe and we say the standard input for this pipe is input.txt. And then we say, okay, cat, embed cat into this pipe and then finish the whole thing. Then finish. And it worked. It perfectly worked. But now at the end of the pipe, we can say, okay, output the result to the standard, to the output.txt. So at the beginning, I can say, okay, pipe this thing into the pipe. And at the end, we can say, okay, so take the output and put it into the file. So there is no output.txt anywhere, right? So there is no output.txt. I'm running the command. As you can see, it said that it ran cat, but it didn't print anything. And do we have output.txt? We do have output.txt, which says hello chat, the same thing as input.txt. One command chain case working perfectly, redirecting perfectly, everything's fine. But for one command, you don't need chains, right? So you can just do that with single commands, because single commands like literally accept std in path and std out path. Like you don't have to do that. The most interesting case is chaining several commands. That's the most interesting case. And for this specific case, let's not do std out, right? So essentially we take the content of the input txt, feed it into cat, then feed it to xxd. So what's going to happen? So let's actually see, is it going to do the thing? It actually did. There you go. So, and Emacs obviously kind of hit some of the output, but there you go. So what's funny is that Nob did a funny thing where it printed each individual subcommand of the pipe it call. Look at that. So we do pipe, then it said, okay, I did cat, then I did xxd, and here is the output in here. And by the way, we can now also redirect the output of this entire thing into the file too. Right, so I'm going to say, okay, so put that into the file. I run it again. It didn't print anything to the standard output. Output txt, well, I mean, it's output. Fuck, I fucked it up, chat. I fucked it up. One more time. One more time. One more time. Right, so output txt and its result of xxd. You can build pipes in C. You can literally build pipes in C. It's that fucking easy. So obviously we haven't implemented quite a few things in here, right? So we haven't implemented all of them. So there's a, yeah, so we need to make it work on Windows. We need to make it work on Windows. And also we need to be able to merge standard error to std out, right? So that's another common thing. We need to support asynchronicity. So asynchronicity is rather interesting, is that, so we have to append some sort of a process ID, to the procs list, right? To the procs list. But do we append all of the IDs we created in the chain, or only the last one? Which one do we append in there? I feel like we have to append all of them, because process ID is usually used for, you know, for different eviction strategies and stuff like that, right? So that's what it's used for. Oh, and here is an interesting thing. If you need to do async stuff, you need to do the eviction every time you create a command. So that means you need to be aware of asynchronicity at the beginning of the chain. So that means you have to say up front in here, do that asynchronously. And then we're going to be appending all of these processes into async. We're going to be appending them into async. And also that means that we have to also provide the max proc, right? So because this max proc is going to be affecting like when we're going to be blocking or not blocking, waiting for more things and so on and so forth. So the pipe doesn't block. It's not like pipe is a sync built in. This is actually a rather complicated thing, right? So in our case, I think we should block somewhere here. Yeah. So the last one, I think you are only interested in the chain as the whole, not individual links, and OS keep track of the chain. I guess maybe that's how it works. Because if somebody dies in a chain, they're gonna close their standard input, standard output, which means they're gonna be closed on their connected processes, and usually that means that it's going to generate sick pipe of some sort, at least on POSIX, but we're also working on Windows. One of them ignores sick pipe. Also good question, right? So, and yeah, I feel like async still in our case, right? So because Nob is not particularly bash, right? It's not bash. It also needs to work on Windows, right? it's a whole different beast. So because of that, I feel like we do need to be aware of asynchronicity. And we work on Windows, right? So PostX is not the only environment where it has to operate. So you have to constantly keep that in mind. All right, so that means what I want to do, I want to actually put asynchronicity into, what is that? Chain CMD. So start OPT, I can't really, begin OPT, I call it begin OPT, right? So that's asynchronicity. And you want to be constantly aware of that in the chain itself, right? So in the chain itself, you keep track of asynchronicity. Let's put it like that. This looks a little bit better. So when we do begin, and we say, oh yeah, we're saving OPT. So begin OPT, what do we say? No, we don't. Everything's fine, everything's fine. So what that means is that in chain, I put async OPT chain, async. All right, so this is the begin, this is the begin. When I do CMD, and you do have async setup, what we can do is something like async, maybe even in the chain itself, right? In the chain itself, if you have async, it is not implemented yet. Chain CMD OPT. So this is async. And then, yeah, so let's try to compile the whole thing. It will not compile because that, but what we have to do is just chain async. So it's a chain async now. So it has to be a special support in all of them. Okay, that's pretty cool. That's pretty cool. So yeah, I think that's everything I wanted to do on today's session specifically. So the rest of the stuff I can probably implement on my own, right? There's nothing particularly special or interesting in here. I established the backbone of the chaining process, and we also established the terminology, we established the naming, right? So, and yeah, so the next knob release probably going to contain some form of chaining of the command, right? Some form of chaining command, and this is something that I needed personally, and also people on the internet requested me to be able to do this kind of stuff, because before that you could only like pipe files but not individual commands and stuff like that. All right, that was a fun session, right? So it's kind of cool, pretty cool. Thanks everyone who's watching me right now. Really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azozin. Love you.